On today's episode, we have Adam Oliner. He's the head of machine learning at Slack. We're going to discuss commoditization, structuring of your machine learning, getting traction for your machine learning investments, and how to think about machine learning projects. This is going to be a great episode. I'm quite excited. Let's get started. Adam, thanks for joining. Feel free to tell the audience a little bit about yourself.
Sure. Thanks, Rash. Pleasure to be here. I'm Adam Oliner. As you mentioned, I'm head of machine learning at Slack. I came from a kind of academic background, been an entrepreneur, started a company, built machine learning teams before. So been all over the machine learning space and really enjoy the opportunity to be on the podcast to talk about it.
Awesome. Yeah, I appreciate you being on. I know you have a great background. So yeah, let's get into it. I know we have a lot to get into. So maybe we can start with commoditization of tooling and how you see that affecting relevant skill sets. What's your take on that?
It used to be true that doing machine learning required a fairly sophisticated understanding of the underlying mechanisms, how the algorithms work. And you can still find reputable professors telling students that if they want to go into a career in machine learning, they should manually compute backpropagation. Apply the chain rule to adjust some weights in a neural network or something to build their understanding. And by all means, do that. It will make you a better person. It's enriching, but it is not a prerequisite for being successful in the field by any means. Most people are not going to go to one of the AI giants and solve last 2% problems. If you are going to do that, if that is where your career takes you, then you should absolutely go and understand the math and understand the algorithms and the details and so on. But most people are going to solve the first 80% problems. And doing that is getting increasingly easy because the tools for doing machine learning are just getting more mature. Most of the problems that you will address with machine learning don't require advanced mathematics. They don't require deep learning. In general, if you pick a reasonable set of features and train like an XGBoost model or something similar, you might get something that's good enough. And the bar for that part of the process is only getting lower. And this sort of leads me to a topic that comes up a lot in conversations with interns or students or people looking to get into the field, which is, well, how do you make yourself an appealing candidate for a machine learning career? And again, at one time, it was like you go to Kaggle and you compete in some competition. If you get a reasonable score, then you put that on your CV.
It's a gold star.
Exactly. Wow, this person must really know their stuff. But that's not really true anymore. And if you look at a lot of Kaggle competitions and you look at like the top 300 entries, the scores are very similar. And really like the fact that you placed 250th or versus 10th, your score is sort of only marginally different a lot of the time. And what that says to me is that really, you were able to do basically the same thing that everyone else did. Maybe they were clever about feature engineering or they happened to know some parameter to tweak. So they got a better score, but only by a little bit. And that's great. But again, you're not going to be alone in your career. You're going to be part of a team. And that clever trick that got someone to 5th place as opposed to 300th, someone else on your team might suggest that. And so I don't see, they got to 5th place, therefore they're brilliant at machine learning. It doesn't quite do it anymore. So, then the question is, well, what do you do?
Exactly.
This is something that I talk a lot about. So I'm happy to talk about it here.
Sure.
So the TLDR is solve real problems. Like when I post a role that's open, I'll get hundreds of applications. Most of them will have GitHub linked and they will have maybe a Kaggle entry or something similar. So that doesn't distinguish you as a candidate. That gets you into the top 200 candidates or something like that. But if you have just gone and solved real world problems with machine learning, that immediately brings you to the top of the pile. So let me talk a little bit about kind of the elements of that and why it's such a real distinguishing characteristic. The first and most important thing is picking the right problem. As a PhD student, this was the skill that is perhaps the most valuable thing that I learned was picking the right problem and formulating it well. The experience that I had as a PhD student was going to my advisor and saying, hey, I have a great idea for my thesis. Here's the problem statement. And my advisor would say, that is a really good problem statement, but it was solved by, the ancient Greeks, and the fall. And I'd say, okay, great. Let me go back. And I would think about it some more and I would come back and he would say, well, that's really good, but it was solved in, the 1950s or something. And I would say, okay, well, I'm getting closer. And eventually I would come to him and I would say, here's the problem statement. He would say, huh, that is a really good problem statement. And then he would get up on the whiteboard and then he would solve it. I'd say, damn it. Okay, well, that's not it either. So let me try one more time. And so, you go through this process for months of, reading papers and trying to understand like, what is the real problem and how do I formulate it in a way, not just so that the problem I'm solving is important, but so the answer in some sense becomes straightforward once you formulated the problem well. This is an extremely hard skill to learn. And if a candidate looking for a role on my team, for example, demonstrates the ability to do this, it immediately distinguishes them. So picking the right problem is super hard, and it is something that as a skill cannot be undervalued.
Do you think then, if Kaggle, exercises, projects are kind of, even keel for everybody, going on your own and trying to, like you mentioned, find a problem to solve and then going through the process of solving it and then putting that on your GitHub and using that as a means to say, hey, this is what I've done. You think that would be more useful time?
I think so, yeah, because it requires that you solve some of the harder problems in machine learning. And picking good problems is one of those. The other one is sort of real world dirtiness of data sets. And there are a lot of elements to this. And Kaggle competitions sort of explicitly abstract away all of those challenges. They have a nice tabular data set with nice clean labels, more or less. And that's what you're doing machine learning on. And man, I wish that most of the problems that I had, someone handed me a nice tabular data set with good labels. Like most of the problem is solved at that point, honestly. In real life, there's the challenge even of just finding the data in the first place. It might exist in, client logs. It might be in, metrics, it might be all over the place. And you have to pull those things all together. And that's not just a problem of sort of engineering. And it might be a problem of engineering at scale, but it could also be a problem with like legal or privacy concerns. Like if there's fields that contain PII on one system, you might not be able to move that to another system. So even just getting the data in one place is hard. Then you have to do feature engineering, figure out what are the characteristics of this data set that might be predictive of whatever problem I care about. You have to figure out labeling. That's often extremely hard. And sometimes getting good labels is everything. And if you could do that, then the problem would be solved, but it's really hard to do it. All of those things get abstracted away when you look at competitions that sort of level the playing field by solving them first and then saying, here's a nice clean data set.
Yeah, and I was going to follow up to that saying, when you get into then an interview, right, are you seeing the better candidates articulate their problem solving skills rather than their technical skills? And are you saying that should be a focus point for people as they are interviewing to really focus on this is the real problem we solved and this is how we did it?
Yes, and I think this is true of any great company. They should not be hiring for a particular tool set or demonstrating a particular skill. It's all about an ability to be smart and solve new problems as they come up. Because, if you get hired onto my team or really any team at a great company, the tool sets are going to change in a couple of years. The problem that your team was working on at the time you got hired is not going to be the problem that they're working on in a couple of years, probably. And so if you're a one-trick pony, if there's one thing you do really well and nothing else, then you won't be able to adapt to that. So if you can demonstrate an ability to be a good problem solver, to pick up new skills and just kind of be smart, which is difficult to demonstrate on a resume, I admit, that is something that will absolutely distinguish you.
I was just trying to think off the top of my head, how do you actually articulate that on a resume? And I think maybe you just put solve this problem. I think it's some people, the tendency is to try to make it more complicated than it is, but you just call it out and just say, hey, this is the problem we solved and this is how we did it, or this is the tools we used to solve it. So it sounds like maybe just simplifying it and getting to the crux of really what you did and how you did it. That sounds like it's a good formula.
Yeah, communication as a skill is, again, a way to distinguish yourself, and not just during the sort of sales process of getting an interview and getting hired, but as an ML engineer, as a data scientist, being good at communicating why a problem is important, being good at communicating why you solved it the way you did, or the value that was delivered as a result of solving it. Those are super valuable skills.
It's funny because a chief data scientist, John Mora, that I had on couple months back, he actually has his team public speak to defend their positioning. And to your point, if you can't communicate why you think we should be doing X, then maybe we shouldn't be doing it. So I think your point on communication it's thinking like that. If you have to be in a public forum and defend your stance, like if you were at court, if you can't, then maybe you should be, kind of second guessing what you're doing and why you're doing it too.
It demonstrates a lot of the critical thinking skills that make someone a good data scientist in the first place. So do you have clarity of thought? Are you able to articulate something concisely because you really do understand it and you don't bury misunderstanding with lots of technical terminology or saying vague things multiple times to try to make people think that you really understand it? If you can just get on a slide and have one bullet point and everyone looks at it and go, okay, I understand exactly what is happening here, that means that you understood the problem better and you're able to convey it better. And as you mentioned, there's also the sort of adversarial angle to it, which is if you present an argument and someone says, oh, what about X? And you haven't thought about that and done the analysis, then maybe you didn't do a good data science job or really engineer the problem correctly. And so the communication skills force you to sort of engage adversarially with yourself and say, well, what about this part? Like, I can imagine I'm going to present this and someone's going to ask this question. Do I have a good answer for it? And thinking about your problem that way means that you will attack the problem and solve it in a better way.
Yeah, I think an interview strategy I got from a VP a long time ago was anticipating every single question possibly. And this gentleman was going for a huge position. And he literally showed me like 4 pages of questions that he had written out that anticipating what he could get asked and having the answers ready. So I think, thinking about your problem that way too, where are the holes? What could somebody kind of, think, this might not be a place that could go well. Being prepared like that is huge to success.
And it's not a terrible way to drive your career forward either. If you think about your dream job and what are the characteristics that someone's going to look for in a candidate for that dream job, and think of where are the places where your resume is weak and try to drive your career to fill in those gaps so that by the time you're sitting across the table or across the VC from your interviewer, you ticked all the boxes and have good answers to those questions. And sometimes that means, taking an interesting internship or going and solving an interesting problem and posting that code on GitHub and writing a blog post about it. And it's not a terrible way to structure your approach to getting that dream job.
Yeah, and I think sometimes people, their self-awareness level isn't as high as it needs to be. And I think if you're not sure where your weaknesses are, or even your strengths for that fact, if there's colleagues, a boss, maybe even a former boss, I think asking, people are very willing to say what you're not good at. So you just have to ask. So I think it's something that sometimes people kind of scratch their head and they're not sure how they can get better. And I think if you have good people around you or people that you've worked with, I think they would be more than happy to give you advice in areas. You just have to be receptive and open to it because it might not be what you want to hear. But to your point, I think it's a great way to improve yourself. And obviously, hopefully that translates into improving your career too.
Yeah. And, we both knew that this was eventually going to turn into dating advice, but interviewing is a lot like dating in the sense that, it's a sort of a numbers game. And the more dates that you go on, the more people you interact with, the better you understand your strengths and what you bring to the table. And it's ultimately not personal. Like I have had great candidates come across my desk and said, this person is amazing. I would love to work with them, but that's not what I need right now. Like there's a particular role that I need to fill and they need to solve the following problem today. So it's just not a great fit. And that doesn't mean that you should take that rejection personally, right? And I think this is something that some candidates maybe don't understand is that it really does not have to be personal. And not only that, but if you go through the interview process and don't end up getting an offer, most recruiters and hiring managers are perfectly happy to explain to you why, because for them, it's not personal either. It's, you were a great candidate, but we felt like your communication skills weren't up to snuff, or you didn't really talk about collaboration in the way that we feel would be healthy for you to be part of a team and solve these big problems. And the more you apply to roles, the more you interview, the more you ask people for critical feedback, the better you're going to understand your own strengths and weaknesses and how to convey those in a resume or during an interview. Because it's perfectly fine to say in an interview, this is the area where I am weakest, but these are the strengths that I bring to compensate. I would want to work on this area with you as part of this role. And some hiring managers genuinely appreciate that sort of candidness.
Yeah, I think being practicing your craft or anything you're trying to improve is obviously always a good way to improve. I guess switching gears now, I know you've built a lot of different teams. I know you were the first machine learning hire at Splunk, and then you build that team to 25. So I know you have a lot of thoughts on how to structure your organization for success, kind of getting that buy-in for, investment in projects, and then obviously what those projects need to look like to get to a successful place. So maybe we can start by how you go about, structuring the org to focus on machine learning and then kind of make sure it's a successful situation.
I'm generalizing a lot here, but usually what you find at successful AI companies is there is a central ML infrastructure team. And they build the infrastructure for training and validating models, for doing prediction serving, for monitoring those models in production, and so on. And then there are a bunch of feature teams around the company that are making use of that infrastructure. So this is sort of the model that you see at Google. So every engineer gets trained sort of as an ML engineer, and they will all make use of that centralized ML infrastructure. That works if there is inbound demand from those feature teams and from the product organization. And if there's not, then an alternative is that you staff that central machine learning team as a full stack team. So make them cross-functional with designer, front end, mobile, set them up so that they can deliver end-to-end functionality without having to rely on inbound requests from other teams. And those are the two models that I've seen be most successful. There's one model in particular that I've never seen be successful. I see companies do it, and I always wonder why. And this is sort of what I call the consulting model. And this is where you have a centralized machine learning team. That's where all of the machine learning expertise at the company is kind of concentrated. And whenever a team wants a machine learning feature, they pull a resource from that team into their team, and then they build the thing and ship it. And then that ML engineer goes back to the central team. I've never seen that be really successful in the long term. And there's a long list of reasons why. And so I'll talk about that a little bit just because I think it's helpful to understand why the successful model tends to be successful and why this one doesn't.
Most definitely.
I think the first thing to understand is that there is never a feature really that requires machine learning. As someone who does this for a living, I can't believe I'm saying that out loud, but it's true. There's no problem that you can articulate that can't be solved without machine learning. And it may be solved much worse without machine learning. So if you're trying to do, object recognition and images, it'll be really bad if you don't use machine learning, but you don't have to. There are heuristics that you could apply that would get you maybe 10% of the way there. And for some applications, that might honestly be enough. And so because it is in most contexts kind of optional, you won't get that inbound request as much. People won't see the value of it. They'll say, well, I'm trying to minimize risk. I'm trying to minimize cost and just get the feature shipped. And so I'm going to do it without machine learning. And so immediately you have made yourself as a team optional. And that's never what you want to be. You never want to be someone's side bet or the thing nice to have. You want to be the thing that is necessary to solve a particular problem. And so teams are avoiding risk and overhead. And so you are now not in a great position of leverage. The second is a sort of more engineering problem, which is the machine learning team doesn't own the ship vehicle for the things that they build. They don't get credit when the thing does get shipped. And so they don't sort of build that organizational leverage. Even when they build something that's awesome and delivers great customer value, it's the feature team that gets the credit for it. And when headcounting conversations happen, it's the feature team that's going to get staffed. So that's not great. The next is that the ML team itself owns a sort of non-decreasing set of features. Every time they go off and build a thing, they become the expert in it. And then they move back to the team and they go build something else. And so the list of things that they are sort of the experts on, that only really they understand at a deep level, only grows over time. And so when something breaks and they need someone to come and fix it, there's this finite and effectively shrinking pool of people who are going to need to fix it. And that's not a great situation from an engineering perspective. If you imagine sort of the career of an ML engineer, they want to own big, impactful things that they can become experts on and develop over the course of years. They really want to invest in something that they can be proud of. And you don't get that when you just sort of drop Trooper into some feature team, build a quick thing, and then leave. So broadly speaking, these are kind of the reasons why this consulting model fails.
So the assassin approach to being a machine learning member of various teams is not the best way to go.
Yeah, so don't do the consulting model. Okay. Ideally, again, have a central infrastructure team and make sure that the organization is clamoring for machine learning.
Yeah, no, that makes sense. I think you got to have that demand. And if the demand's not there, then, maybe you got to relook at what's happening internally. I know getting investment, getting buy-in from executives budget wise is always a difficult task unless they are the ones with the initiatives. So how do you go about getting traction for different projects, investments? What's kind of your strategy to make sure that those investments, one, are going to come, and then also how you kind of align those metrics with the company's objectives?
So the first thing I should say at the outset is I have not solved this problem.
Ongoing.
Yeah, if I knew how to create demand for machine learning under any circumstances, then I would be king of the world. But there are certainly strategies or tactics that you can employ that try to do the best you can. The first is to have metrics, ideally, that have some kind of a dollar sign next to them. I think it's really easy for a machine learning engineer because of how they're trained to say, oh, if I can get accuracy or recall above this number, then I'll really be able to convince people that this is a valuable model or that I'm really going to solve this problem well. But that's not the terms in which an organization typically thinks. They think in terms of revenue or in terms of margins or something similar. So you want to have a dollar sign next to whatever you're building, either directly or indirectly. And the sort of on the tiers of goodness at the top, you have driving the core business. So if the core thing that makes that organization money, you can make more money, that's great. You're going to do well. A secondary thing is to drive a new business. So if there's something that the organization is not currently selling or some service they're not currently offering, but it could be offering and it could be a new SKU or a new business, then that's great. The reason that's not as good as enhancing the core business is because it's a risk. You have to convince somebody that there is actually a market for whatever you're offering and that you can do it and sell it effectively. And so it's a little bit more of a sales technique. The third level on the tier here is efficiencies. If you are a big organization, like if you're Google and you come up with a good way to use machine learning to increase the efficiency of your data centers, then that's millions and millions of dollars a year. And sure, in the scale of Google, maybe that's not a lot of money, but millions of dollars a year for most organizations is plenty. But for smaller companies and smaller teams, the efficiencies are not generally big enough that you'll be able to make more than a marginal impact. And so that's why it's kind of third on the list, is that usually you're operating at a relatively low margin to begin with. And the thing to ask yourself is like, are you a nice to have? Like most of the time when you ask an executive, like, what would you want to do with AI? Like, how can it do for your business? Answers often come in the form of shiny object. Like, oh, it'd be really cool if, and then they talk about, some sort of side thing that they imagine would be fun or cool or whatever. But that does not make you core to the business. That does not make you, add revenue for Facebook or, something where when the executives sit down and they talk about investments for the next quarter, they say, well, this is our bread and butter. So therefore we're going to put more on it. If you're a nice to have, it would be cool if, then you're never going to be that. It's like the old faster horse adage, right? So if you ask an executive what they want with machine learning, they're going to give you some shiny feature. But that's like if you had asked somebody in the late 1800s, what would you want in terms of transportation technology? They would say they want a faster horse, not a car, because they're not kind of thinking in the right terms. It's sort of like that.
Yeah, no, that makes sense. You got to get that buy-in, but you also have to be core to what's driving the business right now, not necessarily what's going to be driving. And I think it's kind of relevant with what's happened through COVID with, I'm sure, budgets getting slashed with the nice to haves going.
Exactly.
So I think when you look at it from a worst case perspective, like we've gone through, that's what's going to happen. If it is a nice to have, it's the first one out. So make sure it's relevant to the core business, I think is a great piece of advice.
Exactly.
Awesome. I know when it comes to helping organizations thinking about their projects, now you've gotten the A-OK, you got the green light. Now it's okay, we got a project. I know you have some thoughts about how to help organizations think about their projects, in particular with failure and iteration part of the deal.
Yeah. So I think a traditional company that builds software thinks about features like, I want to deliver some feature that does X. And so you think about how you're going to deliver that feature, you scope it out and you say it's going to take 3 engineer weeks. And they say, okay, great, go do that. And then you spend those 3 engineer weeks and you build the feature. And a lot of organizations will do some kind of an A/B test. So they'll experiment with whether or not that feature has the impact they hope. Like maybe this feature is designed to enhance engagement or reduce the amount of time people spend performing some task or something like that. And you do the AP test and you measure whether or not it does the thing. And if it does with some statistical significance, then you ship it and then it is done. You check the box and you move on to the next thing. And that's not typically how machine learning features work. Often they are at their worst when they first ship, because sometimes you don't have a mechanism to gather the data that you need to train a good model until you have already shipped the thing and you have some sort of usage or engagement already. And so if you employ that same line of thinking that I just described to a machine learning feature, often you will say, it's not very good, or it's not good enough that I want to ship it. Therefore, I'm going to abandon it and move on to something else. And I think that leaves a lot of really good work on the cutting room floor, where if you had shipped the thing and said, okay, it's going to be mediocre for a month, and we find that acceptable, it's not causing any harm, but we're going to gather some really valuable data, and model 2.0 is going to be great. And model 10.0 is going to be incredible and it's going to be transformative. And as an organization, that's a really difficult change in thinking, because you no longer look at a spreadsheet and you say, oh, in 3 weeks, I'm going to have this feature. Instead, it's in 3 weeks, we're going to start gathering data to make this model better. And at some future time, it will be good enough and nobody can tell me when that will be. That's a little bit more of a complicated, risky way of thinking about a feature than just saying it'll take 3 weeks.
Yeah, are you finding that people just try to make the model quote unquote perfect or as good as they can and then go out? Where you're suggesting is, look, it's going to take a lot of iterations. It's going to take a lot of collecting more information to make the model better. So let's get it out, let's test drive it. And then that process is actually going to make the model better rather than trying to spend so much time on the front side.
I certainly think you should try to do no harm. So if shipping a mediocre model makes the user experience terrible or creates risk or something like that, then don't do that. But in general, yeah, I think you should be shipping a lot of things quickly. At the very least, you will get new data and information about what things are impactful, where you see sort of softness in the problem space, where you think you can make forward progress and like push in on that. And gathering that data is invaluable. And so you should ship lots of things and do it quickly and iterate and improve. That's absolutely my philosophy. I think that's not every organization's philosophy. And if you are at an organization where they really want something to be more close to perfect, then it's a little bit more difficult to ship things. And I think that's just an organizational challenge that you need to communicate your way through.
Sure, yeah, I think that's a great piece of advice. It's about being able to get something at a point where, like you said, it's good enough, and then you keep making tweaks and adjustments to make it better.
And you see the value of the data that you generate when you look at how successful AI companies have been successful and sort of the importance of data in that story. So I always refer back to sort of Google versus Bing as a good example of this. There's nothing about the internet that Google sees that Bing can't see. It's all just on the internet, right? You just go, you crawl it, you have the same data sets. The thing that Google had that Bing didn't was usage data. It had people performing searches, being successful or not being successful, and then trying again. And that data was informative for them to understand, what do people look for? How do they search? How do they describe their search terms? What things do they click on? Both the successes and the failures were educational for Google. And it took them years and years and years of iteration, and they continue to iterate to try to make that better and better and better. And the more data that they gather, the more effective they are. And it's really difficult for a company that doesn't have that data to build a feature that is equally as good. But it requires that time where you are iterating and not being perfect, where your users are maybe struggling a little bit and failing, so that you understand both what success and what failure looks like. You have labels that are both positive and negative. And that's a different way of thinking about software than just saying, I need a feature that does a thing.
No, that totally makes sense. I know data and data privacy is a huge issue, challenge for anybody at any org, but I know you have some approaches to data privacy challenges, in particular, when tackling problems with machine learning. So wanted to get your thoughts on that.
Yeah, so there are a lot of things to say about privacy. I think my top level advice was try to make conversations with customers or with users easy. And so, for example, at Slack, we don't look at your customer data for any reason ever. Okay, that was an easy conversation. And you see conversations online of people asking like, oh, I bet Slack is looking at my organization's conversations or my messages or my channel names or my search terms. We don't. Period. And so that's an easy conversation. That's the conversation you want to be easy. Make the challenging conversations the internal ones of, can an algorithm go and look at that data so that we can protect you against spam, for example? So like there's a difficult internal conversation of under what circumstances can a machine go and analyze PII so that we can prevent other people from spamming you as a user. And that's where the conversation happens. It doesn't have to happen at the customer side. So ideally, that is how you structure privacy conversations. That's certainly how Slack does it. And so in that world, you have to be a little bit clever about how you do machine learning sometimes. So for example, a lot of what we do is operating blindly. So there is a firewall behind which we cannot look, but we can send software behind that firewall to go train a model, validate that model, deploy it in an A/B test, and tell us whether or not users were more successful at using the product or happier using the product. And if they are, then maybe we ship the thing. And at no time did we see the data that we were operating on. This is very different than if you come from like a Kaggle background where like the very first thing you do is you open the CSV and you look at the data and you maybe train a model and then you go and you look at the features of that model learned on and try to say, oh, what were the values that were important? What were the features that were important? What were the mispredictions and what can I learn about them? That's the very first thing you do. And you kind of can't do that at all if you can't look at the data set. And that means that you have to have tooling and mechanisms and processes that make it possible to do machine learning in a scenario where customer data is private and where you value that above all else, including success with machine learning sometimes.
Yeah, it sounds like you got to really focus on some of the byproducts, not the actual, beginning, data set point. And by doing that, you guys got to definitely be very creative. But it sounds like that works because in the end, it's still about producing a better customer experience. And that's what you guys are about. And by focusing on that, you still get to the result. It's just how you're doing it is definitely keeping the privacy for the customer at bay.
It's a constraint, but it can be freeing in a sense where you're disincentivized from just saying, I think it would be cool if, the product did this thing. Because if you can't measure whether or not it's good at doing that thing without looking at the data, then what do? But if we just say we want more users to be successful with search or with autocomplete or for fewer people to get spam, like that is an easy problem statement and we can measure whether or not we are successfully tackling it. Great. So we can go and do that thing. And we don't have to look at anything to do it except for the impact that it has.
That's great. No, just looking at the impact. Hey, Adam, it's been a pleasure. I'm sure we could keep talking for a while, but I know you got to get back to it. If people want to get in touch, is LinkedIn the best way to ping you?
I think so. Yeah.
Awesome. All right. Well, everybody, appreciate it, Adam. This was a great episode. We'll be back next time and have a good rest of the day. Cheers.
Thanks, Arash. It was a pleasure to be here.